Hello, I just discovered something funny. I don't know if there's anyone even watching. Yeah, there's people watching, look at that. Alright. So I just discovered on Wednesday I didn't have very many viewers, and it's because I didn't post the thing in Discord. I typed it all up and never hit enter, which conveniently meant I had fewer key presses to type it up this time. Anyway, alright. So here's where we are. We've been working on this game, Warlocks. And we spent several streams, maybe 5. Oops, that's the wrong monitor. This game, Warlocks. Several streams building a talent selector system. So you get this thing here. It's very extendable, customizable, designable. And you run into the world and you can throw spells at each other. Then we decided we need a status effect system, because what makes a lot of the abilities interesting will be things that modify other things. And I will go into that. I started building another file. This will not take as long as the talent selector did. Where did that guy? All right. So basically, there are 5 types of debuffs, and I'm actually gonna add one. Yeah, this guy right here. We'll add that today. But you can stun people. That's useful. Abilities that stun people are cool. It takes with the control. Makes for interesting interactions a little bit. Damage over time and heal over time effects. Slows and sprints. You want to be able to slow people. You want to be able to sprint yourself and not have these interact in bad ways where, depending on the order they apply, you end up in a permanently bad state or anything like that. You want it to always be the correct speed. Damage buff and debuff. Presumably you might want a thing that says for the next 10 seconds you do 50% more damage, or be able to hit someone else and it says they do less damage for a little bit. Same thing with friction. The game is a lot about knocking people off and being a little bit slippery, and I talked about things like a tar patch or an ice patch that make you slide that modify your friction. And gravity, I don't know that we're going to do gravity. I don't know if the game's going to have a lot of jumping, but you could do the same thing for that. And knockback multiplier could be a thing. I don't know we have to add it, but you could have an ability that prevents knockbacks or reduces them. If you know someone's going to hit you with a thing that most of its value is a knockback, you might be able to interact with that. Or the opposite. You might be able to give someone a thing that's like loose feet, so then when you hit them with a knockback, they just go flying off into orbit. That'd be sweet. Always fun. Alright, so we talked about this Wednesday. We went into a bunch of detail about how to build this thing, designed it carefully. Basically, it follows a pattern similar to some other systems where it has a controller. The controller has a server and client script. Part of the reason it's on both sides is it needs to be networked. Every client needs to be able to view what debuffs you have. We were going to make a UI element that shows you your own debuffs somewhere in the corner of your screen, middle of your screen, something like that. And also the nameplates show what other people have, as you can tell. Every debuff has an icon, a name. We have a shared script, an API script that other things can call into. A lot of other systems will call into this, like the abilities that want to apply these things. You light someone on fire, you need to put the fire dot on them. And we talked about the API last time. I think it's still open here. API status effects. So you get the state tracker. That isn't really needed for all these things. We need to be able to define status effects. So somewhere in here there's a bunch of definitions of here's all the status effects we have. And then be able to find out what's on a player and apply one and remove one. We might have a cleanse ability. And here's the types. We ended up talking through it a bunch. Custom, stun, move speed, damage mod, and friction. Custom was the damage over time and heal over time, but we also talked about they could be any sort of funny things. They'll just have some functions you pass them that do something, because they're completely independent with each other, right? It's not like if you have 2 or 3 dots on you, it's not like they interact in some way. They just, each one does damage and that's that. But they could do something very different. You could have one that does damage progressively faster. You could have one that waits 20 seconds and then does damage. Or waits 20 seconds and then throws you up in the air. Or, you could have custom things that just do strange things that don't really interact with each other, but require the system. So we're letting that go with functions. We'll think about it a little more if we start writing these and they don't work out well. If you have a damage over time effect that lasts for 12 seconds, you want to make sure the tick function is called exactly the same number of times, for example. Or called in some way that you can be sure that you always take the same amount of damage. That doesn't depend on frame time slightly to do more or less damage. That feels incorrect. Okay. So We are talking about, we have a bunch of things to do next. Keep implementing the system. These scripts are pretty empty. They're missing some things. They need to initialize some stuff, make the actual status effects work correctly, figure out the tick function pattern, and then start working on the UI, and maybe add the knockback multiplier. We can do all that tonight, I think. One thing we talked about, I guess I just touched on it, is figure out a good pattern for the tick function. We're going to try it, we're going to see how it is, and think about it a little more. I think that it's close to what we need, but maybe there's something there that I don't have correct. All right. So, oh, this other problem. I didn't mention that. So the status effects have IDs. I gave them a number. So I started with this next ID variable, which just sets to 1. And when you define a status effect, it gets that ID and increments it to 1. So the first one defined as 1, the next one defined as 2. And that way, when we track them, this needs to be the same order on client and server. That way you can say, player Zarishmi has status effect 3, and it's gonna expire in 4 seconds. And the client, you don't have to have a name or anything else passed through. You can just have a number. It's always the same size. Names can be very long. You could have the burning, inferno-y, fiery, doom debuff, and you don't want that to have to pass over the network as a large string. The problem is we need to guarantee this order, and so basically I talked about a couple cases. I could define them right here in these scripts, and then they're guaranteed to be in whatever order I define them in. You kind of want this to be a little more modular, where someone could use this system in one game and drag in some status effects that someone else wrote. You know, maybe someone takes this system, makes a bunch of status effects in their game, and someone else takes the system and brings some status effects in from their game, and just wants to plop each status effect has a single script. That'd be very clean. But then you can't guarantee the order they run. Scripts do not run in the order they're in the hierarchy. Generally, there's no guarantees there, in which case this ID system doesn't work at all. I think that is so valuable that it's worth solving this in a different way, which is what we're going to do. We're going to use a hash function. So we're guaranteeing that their names are unique, I believe. Let's see. Type. Maybe we're not. Oh, yes, we are. Right here. Okay. So they get stuck into a table by name, and if the name's already there, it complains. So you can't have 2 burning debuffs. This is not necessarily a requirement for a system like this, but I think it's simple enough and not that limiting. If you look at World of Warcraft, which has tens of thousands of debuffs probably, there are probably a lot of debuffs with the name, burning or something. They do not have unique names. However, that's fine. I think what we need to do is make a hash function, make sure it doesn't collide, and be on our way. Or maybe we don't even worry about collisions. Hash functions don't collide that often. Who cares? And that way we can drag each one into a separate script, and they're easy to add and remove. I think that's pretty simple and good pattern. Right, we don't need a fancy hash function. All we need to do is take this name and turn it into a integer, a number that fits in a number field with precision. I believe Lua actually just kind of works like C++, and as long as it's a 32-bit number, it should work, but I'm not actually sure about that, so we're gonna find out. Let's experiment a little bit here. Test. Yeah. All right, super simple. Print 2147, and you would be really impressed if I remember what this number was. 2 to the 30 first power. 2 1 4 7 4 8 3 6 4 8. So we're gonna try just printing a bunch of things and see what it actually prints out. So we'll take that, we'll add 1, we'll subtract 1. Somewhere it's gonna, because Lua has floats and integers jammed into the same type, somewhere it's going to round or lose precision, and we'll see the last couple digits turn into something else. We're gonna do the same thing for twice as big, because it might have an unsigned case, and they might be 64-bit. We're gonna try that too. Oops. The behavior when you select a line, this is a very minor behavior. When you select a line and drag it and it puts the line somewhere else, I have never wanted that functionality. It is always a mistake when I click on it, and that's what happens. All right, so this is twice as much. We're going to do the same thing for 64-bit numbers. Oh, okay. Google gave me scientific notation, and I had to go to a different thing, which gave me some commas. All right, and 2 to the 64th power. Ooh, we lost it. Well, Rumpf. There's gotta be a button here to do not scientific notation. All right. Let's just hit play and see what it prints out. Bam. Okay. Comparing numbers. So the first 3, the second 3, they gave me exact numbers. Interesting. That one is correct. And the next one gave me scientific notation. Why though? I want to do the next one. I want to do 64th power. We're going to use Wolfram Alpha, which will definitely give me a real integer. Thank you, Wolfram Alpha. How are you not copy pastable? This is astonishing. What I suspect is that Lua has, because it gave me scientific notation, I suspect that means it's switching what type is stored underneath. So I expect, yes, okay. So I think that this is the largest number it stores precisely. And these are probably stored in double precision. If they were stored in normal 32-bit precision floats, it would round about 7 digits in. So we'd have, starting at this 0 here, it would start having other digits, but you see 0, 3, 6, 8, 5, 4. Here, that's exactly what it is. So you can get up to 64-bit number unsigned or signed, and then double precision after that, which is pretty good. Okay. So, hello, Buck Monster. Yo, even. Alright, so we have learned some things about this. All we need is a hash value from a string. And I'm just gonna look up hash function because there's lots of them and they're pretty simple, but people have done so much research into this, it's incredible. This is thought I was experiencing something I've never seen before, but I was mistaken. This website has little code snippets with funny syntax highlighting that almost looked like it had gradients. Basically, the way this works is the hash function needs a couple properties. It needs to be basically a seemingly random number given a string. So we're going to take next ID out of here. Don't need that anymore. Basically, we want to take this string and get an integer out of it. Local ID equals 31, maybe? 0. Start with 0. So we want to take a string and get an integer out of it. We want any single change in that string. If you change any character at all, then it changes the number. And not in a very simple way. Like you could, A equals 1, Z equals 26, and just add all the numbers, all the letters together. But then you're pretty likely to hit the same number with different strings. So basically, any change at all just seemingly randomly changes the number. And to actually use up most of the space that's available to you for your numbers, if we're doing a 32-bit number, for example, so that if you have a bunch of different strings, you're very unlikely to hit collisions here. And you're kind of at odds. That's part of the reason why hash functions, why people tend to use such like large hash strings. You're kind of running into the birthday problem, which is if if I have 4 billion possible values and I pick 1,000 of them at random, the chance that I have 2 that collide is actually not that low. I can figure it out. In fact, I'm a little curious. But basically the point is, as you pick sample randomly, the more you have, the more likely you are to collide. And that is what we don't want. So we try to maximize all the things we can. So I'm looking at a random hash algorithm on the internet that says, all right, so we take each, so we take each character. How do we do that in Lua again? Let's go all the way to the bottom of this page. All the way down to the bottom. Built-in Lua function. So let's get the reference manual open. String.format. It's going to get us to the string section. So 0 more integers. Returns a string with length and number of arguments. No, the other way around. Can I just index a string? Maybe. Internal numeric codes. This might be what we need. We might just be able to index it. Let's find out. We had a test file a second ago, right? Print local a equals hello print a3. No, did not like that. Okay, dot byte 51. Interesting. Okay. So if you give it a single number. Oh, I see. This is supposed to be string.byte. I wonder why that worked. Or if it did. Let's see if it gives me the same thing. 108. Different thing. Okay. I did it wrong. So that's lowercase l. I believe that's... We're going to look up an ASCII table and see if I'm actually getting the right things here. Lowercase l is right here. And it's 108. In oct, it's 100... Oh, that's not oct. Yeah, 108. What did it say? It's 108, right? Great. So we're just going to ASCII that. Perfect. And if I give it more than one number, it's going to return more than one. I guess that's a pair of variables? Strange. Okay. Anyway, we can use this. So this is our function that we need. So, and there's a string length function, right? Is it just string.len? Yes. Okay. For I in that's Python. For I equals 1 string.len this guy. So we want to iterate through the characters of the string. Equals c equals string.byte. You might be able to do pairs on a string or something like that. I'm actually not sure. This is the kind of thing that's slightly easier in Python. You just say for C and string and it understands you. All right, so we're getting these. So we're taking id equals id plus c times, oh, interesting. Oh, huh. Okay, we need the variable. Local, they call it ppow. Modulo That's an interesting algorithm. They just have some hard-coded constants. This is how this sort of thing tends to be. P pow equals P pow times 31 mod the same large number. All right, so I don't really understand this, but let us at least see what this does for a second. I think that this is all we need. Okay. I could put this into function. In fact, I'll do that in a second, so it's not just nonsense in here. But you start with this number, it's 1, and each time, for each letter, you multiply it by 31, and then you mod by this large number to make sure you don't go over that. And then for each character in the string, you multiply this. So the first character is worth 1, the next character is worth 31, the next character is worth 900 somethings, and then you mod that value by this large number and add it to your ID. I feel like we need to mod the whole thing and not the... Yes, I put the parentheses. There are parentheses in here. Here and here. Okay. So you can't go too large. This value is kind of magic, but it's big enough that I think it'll be fine for us. That being said, this is 9 billion and our limit was 2... Oh, no, our limit was 64 bits, right? Yeah, so this is totally fine. Okay. We'll see how this works. See if it works. Let us define a function up here. I don't need it outside of this. So I'm not going to get hash, string hash. String. Her. A.byte3 is actually string.byte3. Oh, I see. Yes. That's why I had the third character. Yeah, got it. Oh, you can just use the pound operator. Interesting. There's a string.life. Sorry, I had switched away from my chat for a second to do the searching for this. And you are correct. I'm doing a hacky solution to this that will work well enough for here, and that's all we need. All right. So we get the character value, we do the same thing we did before. Hopefully this, we'll write some tests on this in a second to make sure this isn't giving us nonsense. And then down here, instead of having this whole thing, we're gonna make it very clear what it's doing. Okay, this way we can define abilities in any order. As long as they have unique strings, they will probably not have conflicting IDs. We could check IDs. In fact, we probably should, because in the rare case someone hits an ID collision or if my hash function sucks, then we're going to be sad. I think the way to do this is to just make a new table rather than trying to iterate through the entire table, because you might have a lot of these defined at some point, and if every time we add one we have to iterate through the entire table to see if we hit a collision, that's an n-squared algorithm. That could get slow. Alright, so we'll use IDs. ID to true. So it's kind of a gross way to use a table. I don't actually need both values. I just need like a set, but I'm just going to set the things that are in the table are used, and that way we can look them up quickly. Why not just use the name as unique identifier? All right. So I talked about this a little before. These are going to be sent over the network, and the names, I don't want to be stuck with the size of the name as a constraining factor. Basically, every client needs to know the status effects on all the other clients, and I want that to be pretty efficient. And I want the system to support names like, you know, super burning, fiery, inferno, death as a debuff name. All right, so ID equals that. So we're going to split this up, and then if used IDs, then we have an error. Oops. As ID collision. Seems very unlikely, but it could happen. Okay, and if that's not true, then we put it in there. Names could be predefined and enumerated somewhere accessible to the client. That is correct. So part of the system is a generalized status effect system where other creators could use this and add and remove the status effects pretty easily if you want to define a new status effect for your game. And then maybe you import someone else's set of status effects, or you use parts from their games and add them and remove them to your game. So I want each status effect to be defined in its own file, so they're very modular and easy to add and remove, which makes it kind of hard to list them all in one place. Especially since if they're using their own script, I can't guarantee the orders they run, so I can't just do the order that they were defined, for example. If I was just making one game, I put them all in one file and not have this problem at all. You're correct. My previous implementation was just to count up. Each time this function's called, the first one's number 1, the next one's number 2. Anyway, I assume this will work, and then it will give me an error and we'll debug it later. All right, let's look at the other things we need to do in initialization. So we don't have any status effects yet. We haven't written these functions, we don't need them yet. Does the server script spawn things? It does, okay. So we do actually spawn the trackers. The trackers have, oh, this is interesting. Helper status effect, player state. So this tracks a single status effect. The question then, I didn't think about this last time, I guess it was late in the evening. Do I want to spawn one of these for every status effect? That seems like a mess. Or do I want to spawn one per player and have it encode the information of all the status effects they can have? And if I do that, is there a clean way to do that? For example, do I just have 8 IDs in here, for example, you know, just a whole bunch of them? Do I... How many debuffs do we really need at once? It's pretty good. If I spawn them on the fly, I could have as many as I want, but that's going to be a lot of objects spawned and despawned, and I'd much rather be sending network properties than spawning objects. Objects have a lot of overhead. I could even limit it to fewer than that. I could do like 4. And we'll see if that hits problems and just define a bunch of properties in one of them. And then is there an invalid ID that we should be using? Should we make sure this is never 0? That's probably a fair thing to do. We'll give it another error. Just there's nothing about the hash function that says it can't hit 0, but I want to use that as special value, and it's very unlikely. So I'll just form has 0 ID. Just want to make sure that doesn't happen. That's not actually what I wanted. I shouldn't have changed that value before. I want that so I know what status effect it is. Okay, so I'm going to edit this thing and call this SE1 ID. SE stands for 1 start time. And then make several more of these. I'm going to make 4 at a time, I think. And we'll see how that works going forward. SE2 ID. Or maybe I want to... Maybe I want the number at the end, because I might have to concatenate these together, in which case it's a little bit more inefficient. No, that's fine. I'll make a function for it. And more readable. It's SE3 ID. And we're doing doing start times instead of end times, or duration remaining. Well, those are two very different reasons. I don't like doing duration remaining because it means you have to constantly change the value. And when you're networking, you don't want to do that. You want a single value one time and then you're done with it. We're doing start time instead of end time because we support debuffs and buffs that last forever. And so they don't have an end time. All right, so now we've got a bunch of these. And I'm gonna start writing these functions. These aren't so bad. Get status effects on player. All right, so the first thing we want to do is get their state tracker. Incidentally, this function needs an argument. All right, player ID. I think we'll do remove by ID. You could have multiple copies of the same status effect onto you, like they're purely independent. And I don't know that there's a good way to say remove a specific, like, would there be a case where someone has two, inlates on them and they want to cleanse and it matters which one it cleanses in a way that the other script will want to specify that instead of just, I guess we could pick like the slot we want to remove or something, but I don't think that matters. I think just remove the thing that has that ID and go on with it. We do want them to stack if two people are using the same ability. We don't want them to be fighting each other. Like if player 1 and player 2 are both attacking player 3 and they're both using the light on fire spell, we don't want that to counter each other or fight each other. We want player 3 to be on twice as much fire. All right, so get the tracker, and then for I equals 1, 4. I want to put that in a constant up here. Even above this, actually. Max status effects. Comments. This must match the properties, the helper template. I'll move this function in a second. It's right here. Get ID property name number n return string.format se underscore ID se. Okay, so that takes the number you passed in and puts it right there, so you get this. And start time property name, same deal. Okay, we'll move these up in a minute, but we're putting them right here now. Tracker get custom property. All right, so this is going to construct this guy and then look for this value. If ID not equals 0, then, so now we actually have one of these. Then we need to put it into our result table. Enter the result at the end. Also, there's a chance I don't have a tracker, is that correct? Maybe. We'll worry about that later. The trackers are supposed to be spawned as soon as the players join. If there's no tracker and this is an error because there's like the first frame or something, then we can just put an if statement around this. That might be a valid case, I'm not sure. We will see where that goes. All right, so if ID is not 0, then we actually have something. You might argue that I should put these, I should order this around so that the ID is a way to get the status effect, and not the name. In fact, that seems pretty true. In fact, Yeah, I don't need to worry about the name collision if the hash function's going to give me the same ID as well. In which case I don't need to have this. Is there a reason I need to be able to look these up by name? Is there a case where you have a name and you want to... Yes, we will need that. When you write a ability that applies one of these, you need some way to know which one you're applying. And a unique name is a pretty good way to do that. It doesn't involve networking, so I'm fine with using names, but you want to be able to say put the burning debuff on a person. So maybe we put these in two different tables. Maybe we put maybe the IDs actually point to the entire data as well. As opposed to just true. Yeah, I don't hate that. This is my name. Name to table, ID to table. Well, we don't need it outside this file probably, because the other files are going to get this entire table every time they want to access them. ID table. That's bad variable name. Status effect ID table. Sure. Oops. Wrong key. Alright, so down here. Alright, so this actually works. Despite this being out of order, seemingly out of order, and I can rearrange it to make it clear. Tables are reference types. No, value types. No, reference types. Yes. So if you add a thing to a table, all the places where it's already in other places, they're all going to be the same table. You can add or remove them, they'll all change. That being said, we can also just stick this up here. And I don't know that we need this. I guess if the name collides, the ID would too, but at the same time, the ID could collide without the name colliding, so there is some information being said about those being separate. And table.insert results. Okay, so if we found a status effect on the person, it's a question of like, do we just put the whole, we can stick all the data in there and say, here's all the data for the status effect this person has, which is useful, but we also don't know how, like we need to know when it started. That's a thing that the UI will need to know. And this doesn't tell them that. We could add that to this table, but then we're defining changing the ability. That's not what we want. We could just store the name or I guess the name. We could yeah, so let's get, we have this guy. Okay, yeah, we'll do this the other way around. We'll give them the name and the duration as the two values, or the start time. Client and server returned name to the start time table. Results. Name. Her. That does fit, okay. Great. Okay, so we take the status effect ID table that goes from ID to status effect data. We index it on the ID we just got. That was on this shared thing. And we access the name property, and we stick that as the key in our result table. And then the thing I said before doesn't work. Aha, we've had a problem. You could have multiple debuffs with the same name. Okay, we we can do this another way. Table.insert result. Okay, we put a table in our table. Yo dog. Probably do it the other way around. Well, data equals table. Data.name. Oops, how did I get down there? Who knows? Okay. So we made a table that has two elements. One is the name of the status effect that is on the player, and one is the start time of it. And then we jam that into with table insert. So this is going to be an array. The first index will be the first. I guess we don't need to use table.insert so much because we know what our index is. Well, no, this makes sense. Okay. The reasoning is you could have, as we apply things, it'll take the first open slot. So you get a debuff in slot 1 that takes a long time, debuff in slot 2 that's very quick, debuff in slot 3 that takes a long time. Wait a little bit, slot 2 goes away. Now you've got 1 and 3, and if you say what debuffs are on this player, you want these to be indexed 1 and 2, not 1 and 3. So I can't use I as the index here. Okay, so if we find a thing, we stick it in a table and return it. I think that's everything we need. Apply status effect. So what do we do if they already have 4? That is the question. Maybe nothing. I've seen systems, very few systems that I'm that familiar with that actually have limits. It's very easy in programming with arrays that you could make some, very large limits, especially since the games that have these tend to be single player, or a lot of the ones I know of. Thinking of, yeah, like they're in a lot of games. Slay the Spire, Divinity, single player games. And WoW, they have a limit, or at least they did in vanilla. That was joked about a lot. But what happened when we got a new one is it just pushed a random one off the end, which we could do. You could just shift everything over, take the first one out of there. That might be a way to do this. Yeah, I don't hate it. Or we just don't apply it at all. Having a hardcode limit actually is pretty helpful for the UI as well. Makes it easier to make sure these things look good. All right, so for I equals 1, max status effect, we're trying to look for an empty slot. I need the tracker as well. It's a lot of the same stuff. If id equals 0, then return. So this is the case where we found an empty slot. I can't call this, I'll call this slot ID because ID is the thing passed in. Server only. Tracker set networked property. Set networked custom property. Set network, I think it's network property. That's wrong. Set networked custom property. Okay. It's the event that has custom taken out, or else the name would be super, super long. All right, so pretty simple. If we find an empty slot, then we immediately set that slot to have the property, and we're gonna copy this. Actually, let's do this, and instead of saying ID, we set right now. Simple as can be. Start time, and we're done. If we found nothing, knock one off, question mark. I think for now, doing nothing is fine. You try to apply it, you can apply. Error. That is a reasonable thing. The question is this an error case or is this a game design case where you have to play around it. Having, at least for now, having it obvious. Although, if it's long as it's on the UI, it should be pretty obvious what's happening. We'll warning. No, it's called warn. Failed to apply status effects. Just so we catch it in our testing. ID to player, because they already have X. Okay. That's useful. We might, forget to clear them off or something and get some weird case where this shows up. Same deal. If slot ID equals ID. Okay. So this one, did we find one that matched? And in this case, it's definitely not an error. If you try to remove something that's not there, sure, okay, whatever. I guess maybe that's an error. Maybe the code that's calling this should, because it's giving it an ID, maybe it should like call this immediately, find one of them and then call ID. Yeah, that's probably an error. Here it is. Failed to remove status effect ID on player. They don't have it. Okay. So it's almost exactly the same code, except for we're checking for the ID instead of 0. And we're setting this to 0 and 0. That is the magic numbers that mean that you have nothing there. It's an empty slot now. There's a little bit here of we're going to think about this a little more. Some of these things actually have to do things, like when you apply and remove them, they have to do something, right? Depending on what kind of status effect they are, they have to change properties on the player, that sort of thing. We could, the way we might be doing this is in this controller server, we might just have a tick function that watches and applies the state. Let's think about this a little bit. Basically, we can try to do this every time something changes, or we can just do this every tick. For custom, they have functions. We need to call the start or the end function if those things apply. We can even add that to the function now if we wanted. And for stun, we need to do something when it starts and ends and not otherwise. Yeah, maybe we need to do this on the edge cases versus the tick function. For these three, it's basically just calculate the new value and apply it. Server only as well. It's unfortunately hard to tell in an API script, in a script that's required, whether or not you're on the server. Waffles is probably going to tell me that you can do some stuff with pcall, is it? The function that eats errors for you, and you can see if something would error. That's right. If you try to do it in the wrong place, you'll get errors anyway. Like it can't call set number custom property on a client. So yeah, see, pcall. There you go. Alrighty. I must wonder. Okay, we're going to move these up now that we've used them a bunch. Server. Server. Okay, well, we've implemented everything. The thing that making it actually do something. We've solved that. We're going to write those later. Make things work. Figure out a good function. Put init in server and client. So this spawns things and initializes all it needs to. That might actually be everything we need to do for the initialization. We need to actually define status effects, but let's move that down here. And let's think about how we make this actually do something. So we're using this in an API script because an ability somewhere might include this API function, this API script, and then call this function to add something to a player. So it needs to say, it needs to do all the right things. It needs to know how to interact with these fields. So we need to add some code in here. What are we adding? What are we removing? And maybe some more helper functions. Name, duration, icon, type. If, okay. Well, status effect data equals ID table ID. If status effect data dot type equals API dot custom. We're basically making a switch statement here for each type. What do we need to do? So if it's custom, begin function, start function, and we call it. Okay. Whatever it is, we need to call it. We might add arguments to that later. For now, I don't know what it would need. There's oh yeah, all these things. The template to spawn? Man. Okay. And we have to have a tick function to check for duration and automatically cleanse things. I wonder how I want to define that. Do I want to define that in here? Have it call into the API? That may be the way to go, because I want that to be server only, right? The client doesn't need to worry about this at all. So server only function API.tick. It's a strange pattern, but I'll take it. Okay. Check for expired status effects. We'll get to that in a minute. So we're getting this one. So we have a start function, which is not required. We basically just said a custom one has to have one of these functions. Then we call it. Multiplier is only used for other ones. ID type. Duration we don't need until the tick function. Name, icon. Okay, effect template is the only other thing we need. And that doesn't depend on this type at all. And this is the only way to actually add a status effect to someone, so I'm getting messages. Are they important? Let's find out. Nope, not that important. Okay. So this effect template, we need to actually spawn this thing. Simple enough, we know we're in server script. Whoops. Sublime does things that are, if I understood them better, would probably be useful. Do I want to, so I want to just attach this to the root of the player. I think that's the safe way. If you have a fire or frost thing, you just want it dead center on them. And let the creator who made the template build it that way. And I can't do that in this function, so roll effect equals that attach to player, I think it's called. Let's attach to play. Yep. Okay. You might also argue that I want to put this in table somewhere, so I can delete it later. That's probably true. I've got an idea. Let's get rid of it. I'll write in the player. And player joined. Player.server user data dot effect templates. ID object. Okay. So this is already a table defined for us. We only need this in server. I talked about this when I did in the last stream that we could make this client only. I think we should. Well, I think we should make it server. No, we're gonna make this client only. Let's get this out of here. All right. Worry about this at a later date. The client can pull this every frame and see what we have, and just see what changes, and then it can spawn it itself and not have to add extra network traffic when we already are being careful with network traffic. It cannot own status effect data because status effect data is the same table that's in our original definition, and it's shared between all instances of the same debuff. So if 4 different people are on fire with the same debuff at the same time, we need 4 different instances in there, or we would. Okay, so we don't need to worry about that. We just need to worry about start function. We got that. Then else if. What other types do we have? If it is a stun, are we adding a stun? Well, whatever. Doesn't matter if they were stunned or not. They now are. So we need to make them stunned. I'm going to stun them in a relatively simple way. Player, probably already in player. Nope. Movement control mode and look control mode, I think, are what I'm looking for. Yes. All right, these two guys. Turn these both to none, and you can't do anything. I realized that it. Okay. Movement and look, that might let you jump, actually. We'll find out. All right. So you just got hit by a stun. You're now stunned. Move speed, damage mod, and friction. I actually have to do this separately because they take the same multiplier and do different things with it. But we're actually just going to be calling a function, I think. In fact, this might end up being a function too. I think it will. Okay, yeah, let's function update player effect state player type. All right, so this is basically going to iterate through the debuffs currently on that person and set that exact. You call it on every transition. You say, hey, we just applied or removed an effect of this type. Go fix that thing. So adding a stun is the easy case. If you remove a stun, they might still be stunned if they have another stun, or they might not. We have to check. If we're adding a move speed modifier, damage modifier, friction modifier, or removing one, we have to go through all of the other buffs do on as well and say what is the current value. The way I'm designing this system is for each of these cases, you take the largest magnitude of the positives and the largest magnitude of the negatives, and you multiply those two together. So if you have a 30% slow and a 50% slow on you, you're still just 50% slow. If you have a 30% slow and a 30% sprint on you, then you multiply those together and you end up with a slight slow, because 0.7 times 1.3 is slow. Same thing for each of these. And it just occurred to me This should be split into two. Damage dealt mod and damage taken mod. Very different things, and they're not. They were not clearly split apart. Taken mod expired. Take less damage. Okay. And I can't have those both before. Simple enough. All right. Back down here, we're going to stick this table there just for reference in a, and then. So if this is anything else other than custom, we probably can just get away with else. Actually, let's copy this up here for a second because we're going to need that as well. Anything else, we can just call this function. It's a little bit redundant, and that's going to go look at the network properties again that we just wrote instead of having the data right here. We still need to look at the other ones anyway. Fine. In fact, I might just call this function right here. Maybe. Okay, we're going to do roughly the same thing down here. So we are removing one. It's custom and it has an end function. Is that what I called it? Yes. Then we call that function. Otherwise, we just update the type. Simple enough. For expired effects, call custom tick functions. Okay. So this guy is kind of a mess. We're giving it a hint. This thing just changed, so it doesn't have to do a we might need more than 4. So we don't have to look at all the other types and try to do all of them at once. That's kind of inefficient. We're saying here's what you got. Name start time. So this function will give us the names of all the debuffs, in which case we can look them up in our big table and get their types. That seems fine versus actually iterating through the effects manually. Yeah, okay, sure. Full status effects. Blank data in pairs status. Probably. The do start function and end function need the player who has the status as an argument. Yes, probably. I was waiting until I actually got to using those to see what arguments I needed, because they might need more. So I just left them blank and said I'll add the arguments when I need them. So all of these have exactly the same logic applied. So we need min equal max equal 1.0. Status effect. This is really not quite right. Calling it, like, this will work. I just calling it data, and what I was going to do is index into this guy with the name. So this feels wrong, right? We're using data to get data. So using the data from the status effects to get the data in status effects. These variables could be better. Or we can write it in a way that we don't have a variable name to confuse someone. So I don't care about the start time in this case, I just care what they have. I call this. It's kind of like the distinction between the instance of a status effect on a player and the definition of a status effect, which is possible. When I started this, I should have put a clear line there and give them distinct naming. I know we've talked about this at work a little bit. Sometimes they come up as stat mods or buffs and debuffs or a couple of the names for it. I think status effect is a pretty good generic name for both parts of it, so that's where we are. This isn't horrible. Okay. If dot type equals effect type, then dot multiplier less than min. I can't call this min, or can I? I can. I was like, there's a built-in math.min, right? But that's not going to redefine it or something. In fact, min multiplier, let's just make this more clear and do this in one line. Min multiplier equals math.min multiplier and min multiplier. And same thing for max. Okay. If effective type equals speed, then almost what I'm trying to do. Alright, so we're basically just doing this pattern because these do different things. We're writing them different lines. Okay, and we also we didn't consider stun at all. Stun is a separate case where we don't even need to. We can just do it up here. Effect type stun. Okay, so that one, there's a little bit of implied player settings here. Like when we set these back, we have to know what to set them back to. And we could, there's a couple patterns to this. We could have a player settings object that we actually try to apply, but then we need everything to be clear for that to work. Like a slow, like that would clear out both the slows and the stuns. We could, on first player connection, we could look at their properties, you know, wait a frame for the thing, for the automatic applying thing to apply, and then look at their properties and store those off into variables. That's kind of an okay solution. We've talked about a potential future solution is to have this sort of thing built into core to avoid that. We could just hard code it in here and say your game's going to work this way, and if you want to change it, we got to change this too. That's not ideal. We will let's make a note here. Get default player settings into variables. Okay. So in the case of a stun, we basically want to do the same thing, only a little bit different. We want to know, are they stunned? Michael is Data, dynamic type equals effect type, sure. So as soon as we know you're stunned, bam, we're done. Simple. As soon as we know you're in, if you get out of this for loop, we know you're not stunned. So something else. Movement settings. Let's look relative and relative. Look relative and relative. We will make ourselves a nice, that's not how you count in this. Nice comment saying, we should probably do something about this. I use exclamation points as a please come back, this is not done, this is very important kind of note. I called this status effects and the status effect. So if it's done, we iterate through, we say, did we find one? If so, do this and get out of here. If it's not a stun, then we iterate through getting multipliers. And then we're going to do something with those multipliers. Simple enough. Move speed. Simple, we're setting their move speed. We need the base move speed. Same deal here. Player dot max walk speed, I think it's called. Right here. Equals 640. Yeah, that's a magic number. We need to solve this. Times min multiplier times max multiplier. That's what we're going to do for all of these. Multiply min and max together. I could put it into a variable. I don't think it's that unwieldy. Friction is going to be similar. What's the default ground friction? Less than 1 the player can slide. How strange. I realize I have errors. What if I make it like 3? Doesn't feel different at all. It's a very strange system. Oh no, it changes. That is, yeah. Alright, this is probably going to be very low for this game. Because if you want ice, even like 0.2, the default is 8 and 0.2 doesn't feel like ice. Still feel pretty controlled. Let's say 0.03, how much am I sliding? Maybe there's another field here also fighting this. Fly mounted. There's a couple of values in script. So if I make ground friction just straight 0, I barely slide. Okay, let's look at the API. There is ground friction, breaking friction factor, and buoyancy. That's it. Nope. Yeah, let's try these two. And ground friction. Ground friction defaulted to 8. Breaking friction factor defaulted to 0.6. Okay. I suspect this will not be as good as that. We will end up tuning this a lot later. Let's work on. All right, damage dealt and damage taken. These are going to do nothing for now. We could store this in a variable in the script and make it accessible from an API function. We could put this in the user data on the player. And we could... I'll answer your question in a second, sorry. And we could directly call into a different API. We're going to make a damage system at some point after this that enables us to hook everything together, to have damages use all these values, to have pop-up numbers and UI and stat tracking. Maybe at the end of the round it says you did this much damage, that sort of thing. All that in the same system, and that this might call into there. For now, do something. We'll just leave it blank. Breaking friction factor, I believe, is actually not in the properties panel. Maybe it's, well, this one says 0. Yeah, I don't see a 0.6 in here, and it said that was the default value. All right, so what is complaining about? 146, a bunch of the same error. 146. Oh, well, that's supposed to be equals equals. And so are all of these. Man, that's embarrassing. This is like programming 101. All right, so it likes that enough. And we've got our remove and add, both calling this function and calling beginning and end. So we're going to move this guy up above. This is all the API functions are together. Throw it in here. Actually, I think these player. Okay, that's fine. Now this tick function. What does this do? It checks for expired things. So first thing we're going to do is call this function. Find out what they have on them. What did I call this variable other places? Status effects. Okay, that seems fine. Effects are my generalized term for audio and visual. In your properties window, I think the thing you have set to 0 is braking deceleration falling and not braking deceleration walking. The rest of the name is cut off. Settings. So I was setting ground friction here. This is braking deceleration for air as well. When I set this to 0, so both are 0, then I still slide around a little bit, or I still grip the ground a little bit. Ooh, this is more slidey than it may look. Just a little bit. All right, so I just got a script error. 109. 109? Really? How is it getting... How is this getting called a nil player? This is getting called with no player. Well, these aren't getting called at all. So it's getting called from another file. Confusing. Okay, we can solve this the other way. So I'm going to edit this, which opens it in the default editor. Let's take a breakpoint on that line. I don't even have the script debugger open. Look at that, script debugger. All right, so you hit this to make it stop when it hits that line. Play. Player. That looks like a player. Okay. Go continue. Hit again. To our call stack. We're ticking. So call the tick in here. Go in here and try to get all the things on the player. Somewhere, oh, that, there's no player. I see the problem here. Okay. I agree with that. Breaking deceleration walking, if that was what it was called. The one of the fields I just set, breaking friction factor, I don't think it's actually in the player properties, unfortunately. All right, so this, we need to do this for every player. Okay, that should fix our error. Let's do that. Okay. Status effects. For what it's worth, a general comment of, yes, I don't think they're there. I think they should be. I would like to improve that. This is definitely in a long list of things that yes, I would like to improve many of these things. I like the systems to be great. We're going for the best bang for our buck. Status effects. So this is the table. It has a name and a start time. We want to do two things. Status effect data equals. Oh, right, for. So we're looking per player per status effect. Somewhere up here we have a very similar piece of logic. No, not that one. Way up here. I think we just wrote this guy. That line right there. Bam. Is duration the name of the field? Time greater than data dot start time plus status effect data dot duration. Then, all right. So this is the data for the status effect in general. If it has a duration, some of them don't. And then we get the start time from the data for this exact instance, which is right here. We add to it the duration. We say, hey, are we past that? Has that much time gone by? If so, we're just going to call this function. It already knows how to handle everything. We're not going to rewrite all the code. Just take the ID off the status effect data. Perfect. And okay, I was gonna say, do we have a problem where we're removing from a table as we're going through it? No, this is fine. We this table right here was constructed for us on this call, and when we remove it, it's gonna get rid of that, but it's not gonna change this table or move anything over or anything like that. It's not gonna call it again. Should be good. All right, and then if status effect data dot type, if we're in a custom case and it has a tick function, we'll call the tick function. We're gonna go with the naive approach for now and worry about it later. Worry about if this doesn't work. Can I fit that into the same line? Probably. Yes. Great. We'll pass the time along. Might be useful. It's probably not how we want that to work, but this is fine. All right, so we have a tick function that's going to check for expired things. If they're expired, we remove them, and then tick everything. Non-custom and custom, these sort of work. We can mark that for now. The damage modifiers, we haven't hooked up the damage system, but the movement stuff should function. Default player settings into variables, yes. And define status effects. And any testing at all. You know, that seems important. Kind of need a thing that can apply status effects to me. We may end up dragging this over to the other map and doing much testing on it before we try to share it, which makes sense. Just use it with the actual abilities we have. I think that will be a pretty good test of it. And we also have to client spawn and destroy status effect effects, you know, the visuals and the audio. All right. So this shared script needs to know the default settings, even though it has a bunch of server-only stuff. They need to be callable from other. Really, remove and add, apply need to be callable from anywhere. Some of these other functions, and this one's used for the UI. Some of these we could move over to server script or something, but that's fine. We need something that says, there's a player joined, set up, look at their settings. I don't know. Let's do a test here. We have a test script over here, right? Not anymore. Now we have a test script over here. So we're gonna do some funny values here. 970 and change this to view relative and change your ground friction to 5. Okay. Function print player stuff. Player. Function on player joined, player stuff, player test. Wait. I'm gonna repeat this 3 times. I suspect that at most it'll take a couple frame delay for this to work. I hope it takes no frame delay. That would be simple. But since this is all server, it's probably consistent if it does take 1 or 2. Print format. All right, we wanted. What did I just change? Let's do this. String. I don't know if it actually knows how to do this. I'm gonna find out. F. Player.max walk speed and ground friction. What was that called? Ground friction. Max walk speed. Okay. Okay, great. Okay, so it turned the anywhere type into an integer. That's fine. It's at least readable. And they were all the same, and they were the right numbers. So there were no times where we had the wrong numbers. We can just first frame. Great. Okay. So on player joined, we're going to add a function over here. A little bit higher. It's going to initialize function API.initialize player settings. There. And what do we need? We need these 5 values right now. My constants are all in a funny order here. State tracker. Like these two, I obsess over this sort of thing more than maybe I should. These two kind of go together. They're very similar. It's just the same data in two lookup factor or forms. Whereas I like having the non-API stuff first and all these functions. So should I move this up here? But then this comment goes with this guy, and if I put this one above it, it's going to be really spread out. Blah. Whatever. Default player settings. This one has to have a comment as well. I need, which 5 did I need? Where did my big function go? 1, 2, 3, 4, 5. All right. Copy this whole block and cut up pieces I don't need. Those 5. Okay. Simple enough. I'm going to copy this to reference in a second. Down to the function we just wrote. Simple enough. So inherently, if you try to use my this status effect controller in a game where you have other things trying to modify these properties, you're going to get into funny states. The system is a way to have these things play nicely with each other, but every thing has to go through the system, right? If you have a sprint ability that comes from somewhere else that just multiplies your speed by 3, this might not work nicely. It might end up in a very funny state. Because I'm resetting it as well, right? So if you let's say you have a very naive sprint ability, it multiplies your speed by 3, and then 5 seconds later it divides you by 3. You sprint, and then someone hits you with a slow. So you use from the game that's already there. So you went from 640 speed to 1920 speed. But then someone hits you with the slow, and our system doesn't even know about the sprint, and it says, oh, now you're 50% slow to your 320 speed. And then the sprint ends and says, oh, 320 divided by 3, now you're at 107 speed. And you're like, whoa, this is very slow. This is not what we were going for. And then the slow expires, and you're back to normal speed, or maybe it expired beforehand, and you're going down to 210 for a long time, or it could be a mess. 213. All right, so at least we have these defined. That's useful. We will call this function over here on player joined. We could call it every time a player joins. I think we just want to call it once. Local player settings initialized. If not, then simple enough. All right, so then these are what we want to use here. Instead of look relative, we just take whatever it was. And whatever it was, you can take that out, these out, and copy these down here. And max walk speed, default, not 640. Great. Ground friction, braking friction. Look at that. All right. Hopefully that will work better. Any errors? No errors. Define some, test some, UI, client-side spawn and destroy effects, knockback multiplier. You don't need that currently. Yeah. So let's define some. let's have an example, to see if this works. So I made a static context for these because I want them to be defined the same on the client and the server. So status effect example dot. Put that in here. It's going to have reference to API, reference to the API, and nothing else. Well, that's all it needs. API is required. So this will be calling a bunch of things that will give us testing and break everything that I wrote because there's no way that was all correct. All right, so the key here is that it's calling this guy, define status effect. And interestingly, unlike some of these systems, the controller doesn't have to run first. We can define status effects, and this knows how to stick them in a table. The controller initializing, all it does is tell it where to put the state trackers. So we need to make this table and call that this guy right here. Simple enough. So I'm just gonna leave that as a comment at the top for now. Local data table, and we call this at the end. Data dot name equals sample dot. Data dot duration equals 12. Data dot icon equals, we don't have an icon. We need an icon. All right, we need an icon. Icon fire. Burn. I wonder if I make a icon reference. Can I double click on it? Yeah, sweet. All right. I almost want, if we just had like a perfect circle or like polka dots, you know, more dots. There's got to be something burning in here that's not just the fireball. It doesn't have to be, but it's possible. Explosion. Damage. Sure. Okay. Why is that called banana? Oh, because I tried banana. Icon. Alright. Icon. Effect template. Well, we're going to need one of those in a second. So that will be another custom property on this. Effect template is what I'm going to call it. So, knowing that these will be spawned on the client only, the effect templates don't necessarily need to be a client context, but they do need to have audio and VFX together. So if I was really being thrifty, I'd put one as the child of the other, so there's only two objects, but that I'd rather just make this client context so that you can reuse these in other places and not have them break or, you know, be networked and be expensive. So burn. Fire and flame burning. Let's oh, that's a whole set. Jeez. I'm amused at it sounds like a wick, but if that was you being on fire, that would be a pretty funny sound. All right, so we're gonna put this guy here. Fire and flame burning. What do we got? Well, you're super dead. Crackle pop, burning furnace. Yeah. I'll just take one of the big ones and turn it down in volume. Let's see if we take the volume, pitch it down and up. This is always my thing with audio. Pitch one way or the other and see what it sounds like. I think down was better. Actually, 0 might be better. Okay, sure, okay. It needs autoplay. It's a loop, so it needs to repeat. This just play as long as you're there. This thing, we don't want to have a duration on this. We want these to be destroyed. by the system. And then we need, let's try fire. Now look at this, there's a bunch more. Let's check out a few more. I guess I am assuming that you're on fire, even though I just said example dot. It could have been poison or something. Oh, these are weapon sounds. Firing a weapon. Fire a torch. Nope. The loop is pretty important. Okay, that's fine. Let's look at these. Torch fire VFX. Fire volume. Oops, that's the wrong button. Fire volume. Yep, that is you on fire. That is you on smaller fire. Just put this on your head. What happens if I scale this guy up a lot? Or scale this guy down a lot? It's very wispy, but I bet there's just a bajillion settings on these things. Okay, I don't like how wispy that is. I like the torch fire a lot more. But it might even be an alpha setting on it. See if I make the alpha lower, if it does something. Does it do anything at all? Hard to tell. Scale it down a little bit more. Okay, that's what it's gonna look like. Take that in there. Autoplay. Great. Great template. Helper example dot effects. We're gonna get a new custom property. Effect template. What did I actually effect? Hey, look at that. Nailed it. Alright, take this out of our hierarchy, don't need it anymore. Alright, so we got effect template, type. Dot type equals, this is custom, right? It's dot. Has no multiplier. The ID we don't define here. If we do, it'll get ignored anyway. And tick function, start and an end. How do we want to define these? All right, so this is doing damage. You're right, we need the player. In fact, that seems, in hindsight, that seems very obvious that all these functions are going to need the player. So, where do we call them? End function, call player, start function, tick function. Player be forward all the time, I think. And start function, player. Okay, easy enough. Inside there. All right, so we can just look at the tick function, just on tick, just do damage. So we want to be as close to consistent as we possibly can. We want to say this thing will do damage every 2 seconds. How would I say it lasts? 12 seconds. And when it expires, if it's, how many times did it tick? If it didn't tick enough times, make sure we finish it. But we don't want them to, I was like, can I keep local state here? I don't want them to interact with each other at all. Like if I put state in this script, then this script is gonna, all of the instances of this dot are all gonna be sharing the same function, so they'll be fighting each other, and that's no good. There's almost like an instant, like a status effect instance ID I'd want to pass in, but I don't know that I need that. There might be another way to do this. I could define the tick function in a slightly different way. That might be the way to do this. Define the tick function in a way where it gets called once a second. That's that. You can be sure it'll be called exactly once a second, on average once a second. And if your dot is 12 seconds long, it'll be called 12 times. I like that. Let's, for custom type called exactly once a second on average. So if the server has some huge lag spike, it'll call it a bunch of times. Sergeant Smoky, can Core utilize gameplay ability system, considering it's a UE4 plugin? I don't actually know what that is. Gameplay ability system. I guess the short answer is maybe. New gameplay ability. I would have to talk to my coworkers. I don't know enough about this system to give you an answer. You're correct. It is Unreal. It can use some Unreal things. Some things we've written enough differently or have different limitations. What we find a lot of the time is yes. What we find a lot of the time is that certain systems either don't support networking at all. It's a lot easier to write single player stuff. So we'll sit and we'll say, hey, check out this really cool plugin that handles this really well. We look at it and it doesn't work with networking. And we're like, well, that really is a bummer. The other thing we found is sometimes they are great if you're using Unreal to make a game. But if we making Core want creators to be able to configure things and change things and set things up their own way, they're not defined that way at all. They have to be defined once when you make the game and then you compile and that's that. And so they're not reliable. That being said, there are many things out there that are helpful, and Unreal's ecosystem is huge and has lots of pieces we're not familiar with. So I will leave the tab open and see what people say. Maybe people are already familiar with it. Yeah. Specifically, the networking came up recently with something about someone had a plugin that did some really cool gravity things we could run around the outside of spheres, because Unreal kind of forces gravity to be down, and they're like, I want to run around on little planets and jump from planet to planet. And someone found a plugin that looked really good, and then it just doesn't do networking whatsoever. And it was really a deal breaker for that. Well, using that plugin, it was a deal breaker for. That being said, I would like more gravity. I would like gravity to be better. I played Serious Sam many years ago, and it has some levels where you run on the sides of things and upside down, and I don't know, I think that was a silly gimmick, but I think it's a lot of fun. Alright, so we were doing something here. We were defining this tick function to be exactly once per second and making sure we don't miss it. So we're going to have to do this a little differently here. We're going to have to add some feature in here to make that work. But for now, what we're going to do is data.tick function equals, let's just define it right up here. Function tick. I can't call it tick because then it'll actually be called the other way. I have to call it something else. Maybe I should even call something else here, like effect tick. And then if it's called exactly once a second, it doesn't need delta time. Okay, we're getting somewhere. I wonder if I give it a different argument, what it will do. It doesn't care what I call this argument. If I give it an argument called player, and it was just called tick, it would still call it and pass in the time. And I'd be very confused. All right, player dot apply damage dot new 5 scrappy dot. All right, we got a tick function, and that's that. This is an example dot. That was pretty simple to define. We had to make a template for its effect. We had to make an icon, or pick an icon, but this was not bad. This will not error. Will error. Yep. Okay. Call the API appear, an API down there. 47. All right, finding all those errors that I wrote a while ago and haven't actually found yet. Get string hash. Found the problem. Hadn't called this function yet. Okay. Great, no errors. Well, I'll just do the thing I just said before I forget, which is change how this tick function is called. So what I want to do, we want to keep track of it, how many times it's been called, and make sure we've called it the correct number of times. And on top of this, in remove status effect, I'm going to check if it's behind. If it gets cleansed, then actually we can have a better solution. I'll say if it gets cleansed and it's between ticks, whatever, that's it, that's the end. But if it expires from time, we want to make sure that it actually got called the right number of times. And I might be able to do that by just moving this up here. I think that's actually what I'm going to do. Then I'll have to write it one place. All right, so we have this data on the player. This is the instance data. Where is the data even defined? Status effects. Status effects on player. I almost wonder if we needed the system I was talking about, some stored data for every single instance of a status effect. Currently, we're using the custom properties, which is fine, except for the server. Except for we need one more that doesn't have to be networked. But we need to be able to set it, and so we can't put it in the same place, because if it's not a network custom property, we can't set it. If it is a network custom property, it's making network traffic we don't care about. We're basically saying how many times has this ticked. We need to store that somewhere and remember it. Where do I want this? So we know this is the only place that status effects gets removed. So we can make a table in this file as the server-side table that says, here's what effects each player has. It kind of mirrors the network properties, but has the tick data. Or we can put it It's kind of ugly. Player index int. I guess this is a table of tables. Stream of me sitting here thinking. We could leave it how it is and have each dot handle this itself, but I think that for simplicity of writing this kind of thing and making it consistent is good. Like, you don't want it. If I just gave it a normal tick function and expected everyone writing these to be carefully maneuvering around those edge cases, then you're gonna end up with a bunch of dots and hots and that kind of thing that like work most of the time, and sometimes when your frame time's a little long or you have a little bit of lag and something, then it doesn't work the same, and that's gonna feel really weird. Having your dots sometimes do 25 damage, sometimes do 35 is not what you want. So giving consistent behavior right here is good. player can't have more than one of these, so how do we ensure it's the right one? More than one of the same ID. We have the 4 slots, it has to basically match these 4 slots, right? Here's where we're adding one. Tick counts. Dot tick counts. Player, then sucks I have to do that. I could have like I could pass through player joined and player left to here, or like I could just define them in this file, but then I'd have to know that I was on server, not client. No, I could. I don't care. This client has a little bit extra data on it. It's ugly, but all right. I'll look these up in a second. Basically, this is ensuring that the tables exist. Don't need that anymore. The client will have these tables. They'll have nothing in them. I accept this as a way to make this code a little simpler. All right, tick counts. Player. Can I just double index? I hope so. All right. So I index by player and I get a table. Then I index by I, because it's whatever slot we're in. Yeah, slot ID is the ID of the effect that we're applying. Okay, so we're applying a new status effect. It has no tick. Great, simple. We're going to move these up to the top to here. We're going to them up at the bottom. I've never done this in this kind of file before. Get, nope, that's not it. Game.player joined event. Let's hope that works. All right, so simple enough. Tick counts. I'm actually going to just jam these all together. It goes with the network properties. So it's a very similar thing, even though it's stored in a different place. Down here, same thing. Remove it. It is nil, I think. If we're removing the thing, then don't worry about it at all. It's just gone. That's that. I like that. And in between, we use it. Interestingly, I can actually get I right there, right? Because status effects came from... Oh no, I can't. That's horrible. I have to rewrite this a little bit. Okay. So this is the thing I talked about 40 minutes ago, maybe an hour ago, which was that if you have slots 1 and 3 occupied, the table that this function that get status effects gives you uses indices 1 and 2, not 1 and 3. And we need to get the same index so we know we have the right value. Because this table isn't sliding over or anything. I could, you know, this is getting to the point of cleverness where I'm not even sure it's going to work and it might break horribly, but I could just remove it from the table and insert it up here. And then it will match the other pattern. I like it matching the same index as this. That feels cleaner, but then I have to rewrite this a little bit to have similar logic. We could do that. It's less likely to have some horrible problem in it where I sit there for a while debugging and say, man, I was way too clever and this just doesn't work at all. All right, so the problem is I don't want to call this function anymore. I want to actually iterate through and look at the custom properties to see what our actual indexes are. So for our player, we're going to copy this entire thing and paste it right there and indent it a little bit and see what we got. All right, so we got a tracker and ID. ID is not equal to 0. We have an actual ID. then okay. We don't need to set the ID. We do care about the start time though. Let's see where that line right there. I'll copy this down for a second. Okay. So instead of calling this function we already wrote, we are iterating through the custom properties, saying, hey, do we have an ID? Okay, if it's true, then here's the start time, here's the ID, these are the things we just got from this. The data itself, we can get out of this table. Same as before. We don't need the name, because we got the data. We don't need a tick count, so we'll get back to that in a second. And then it's custom or duration. Okay, I think we can just clobber this right here. I'm at least pretty sure that worked. So if it's a custom and it has a tick function, then we call the tick function. This is what we're going to change in a second. If it has a duration, start time is no longer data.start time, it's just start time. Then we remove it. And we don't even have to, we can also remove that. We've got ID right here. Okay, great. So now we actually have the index we need. That is great. We're going to take this guy and paste it here so we know what we're doing. So this tells us how many times we have tick to this thing. We don't want to tick, we want to tick once a second starting a second in. We don't want to tick immediately, that's what the start function is for. We do want to tick at the end. I think that's just for simplicity. If you want a 12 seconds dot to do damage every second, you want to do 12 times. You don't want to do 11 times and have to worry about the end function. But if you want something right on initialization, that's kind of a rare effect. Maybe this is just my experience with RPGs I've played. So if it has a tick function, then we need to figure out if we should call the tick function, basically. And here is, if we call it, we're going to increment this value, but we might not call it. So if thing, then it. Start time. Oh, you know, we can do the for this is cheap. Time elapsed equals time minus start time. Oh, this is great. I like this a lot. Ticks expected, we'll call this math.for. All right. So if this is less than a second, then this number is going to be 0, right? If this is exactly 1 second, time minus start time will give us 1, or up to 2 seconds. That's great. So exactly at 1 second is when you should get your first tick. Up to 2 seconds, you should get your second tick. This tells us how many we expect. For I can't use I, we already have an I. J equals tick count, ticks expected. Okay. I equals, I need like a -1 in here. I'll figure out which way, I don't need this. So this starts at 0, and 0 to 0 will iterate 1 time. It's saying I could put a plus one on this one or minus one on this one. I figure out which way it makes more sense. Basically saying, hey, we've ticked 0 times and we expect 3 ticks. We had a huge lag spike. Let's tick 3 times right now. Let's do a +1 there. Sure. And then we can move this out of the for loop. I realize it's more lines. Incrementing it seems ugly. We could increment it multiple times and we can just do this. No, I'm gonna move that back. Almost all the time it'll happen once and it's much more readable. All right. So here, this is great. So first we're catching up. We're getting exactly how many we need. Second, we don't have to worry about the end case because if your thing is exactly 12 seconds long, the only way that this case is going to happen is the time is, this is 12, so time minus start time has to be at least 12, which means that this has to be at least 12, and it just did it. It just fixed itself. You cannot expire without having ticked the right number of times. I hope. Okay. Bam. Require failed. Error command Lua script 298. It did not like that. Oh, you can't put these after return. Returns when it ends. Mm, 108 and 112. Okay, so here's the problem. This variable is defined right here, and it's accessed up here. So we need to find it up here somewhere. Okay. Bam. I put it there because it's not a constant. These are constants, they go first. Alrighty. We defined a satis effect. One example. That's all we need. Everything works perfectly. Some sarcasm. Testing it all. Client spawn and UI, those will be a fun bit in a second. Let's do some testing. I'll probably make a couple more examples and a system to apply them. Let's see. Let's get the API here. The API. API, C, function tick. We're waiting between 3 and 6 seconds. 3 and 9 seconds. I think the last 12 seconds. I mean, we kind of want to not light myself on too much fire. And then for player, I realize there's only going to be 1 player, but we're going to test 2 players eventually. All right, we need to stick a dot on us. That's what we want to do. That thing right there. All right, we have a player. ID. Well, that's a pain. How do we get an ID? Oh, right. We can access this thing. And just give it a name, which is example dot ID. Is that how I actually want this to work? Is this called other places? Where is the ID? I feel like these should be by, well, I feel like they should be by name. Which would not be too hard. Let's test it, see if it works first. So this is just going to randomly let me in fire. It's plan. It'll have no visuals. Print string.format applying example to me. Even though it worked because it'll print out a script error. Ha! Nailed it. Seven. Status effect definitions. Really? I can't access that? Really? You let me... Oh, I didn't require. Ha! Okay. That's definitely the only problem here. Okay. API status effects 279. Status effect data. Status effect data. Index a nil value. Did I spell this correctly? Yes. So this table did not have the ID in it. Or the ID was read out of the tracker. Let's wait for that to error, then hit tab. What's in our tracker? Oh, that's a real number. Look at that. And it's negative. All right. So our hash value, well, it was a valid Lua number. When I tried to set it to a custom property, it didn't like that. Would be my guess. It got clamped to a 32-bit int, and it was too big. Too big. That is my guess. Start time is reasonable. This is number of seconds since, does that seem right? Number of seconds since I opened the editor, which was just for the stream, so a little more than 2 hours. 2 hours would have been 7,200. That seems correct. But our ID, not so good. Let us add a print statement to verify this. Define status effect. Print ID. Bam. There's a number, it's not negative. And when it applies to me, and errors. Okay. So this number is 7 billion. That is more than a 32-bit number can do. I am going to pull up my old trusty TI calculator. 7082332961 minus 2 to the 32nd power. Okay. That got it smaller. Let's do it one more time. Get it into the signed integer range. -150760161. That is it. All right. This was too big. Just a little bit too big. Let me do some with our hash function so that it doesn't go too big. We can just mod the answer here. We can pick this number to be smaller. So this number is 9 billion, and our range is about 4 billion. I don't know what these numbers probably have very specific properties about relative primeness and that sort of thing. I have not researched this much. Like I said when I did this before, people have researched this so much more than I ever will that it's just safer to look at their stuff and not worry about it too much. We're gonna mod this by, I want to do 2 to the 32nd, and then, all right. So I can take this and mod by 4294967 All right, so Lua is using 64 integers. This will be fine. This will give me a number between 0 and this number minus 1. But I actually want that to be it's signed, not unsigned. So I want it to be to compare. Okay, when I store it into this property and read it back out again, I want to get the same number. So I subtract 2 to the 31st from that. This is one way to do this. 2, 1, 4, 7, 4, 8, 3, 6, 4, 9. But I can actually just define these as this. And it'll be more obvious what I'm doing. Lua is one of the few languages that actually defines this operator this way. I need to make sure I'm not off by 1 here, which is to say an unsigned number is defined from 0 to the power of 2 minus 1. A signed number usually has more negative numbers than positive by 1. Maybe not for a very obvious reason, but just it's a 1 bit less of positive, and then you take all the rest and make it negative. So if this operator will give me 0 to this minus 1. If I subtract this, then let's look at a very simple case. 0 to 1 minus 1. Yes, okay. This will be, I guess, it's not more negative than positive. It's 0 is a positive in the even split. Anyway, I believe this will work. We're going to find out. Print out our thing again, which is a 0.0 now. Applying dot. Now let's get a health bar in here so I can see if it's hurting me. Health bar. Boop, boop, boop. Look at that. Once a second taking damage. It's supposed to do 5 damage 12 times. Oh, no, I'm taking 2 because I have 2 of them on me. And I'm going to die. First one expired. Bam. All right, if I write this to mass.weight 100, just only apply one of them. And comment this one out so I get dotted immediately. That might not actually work. It did. All right, I want to make sure it does exactly 60 damage. 12 times 5. Perfect. All right. Multiplayer. World of incoming script errors. Taking damage. Okay, this was in a tick function. So as soon as a player joined, it hit this and applied a dot to them. Okay, can I do this, a reasonable test with 2 players? Nameplates in so we can see both people's health. Sure. Player joined. Player. Oop. Two players. Both players. See, the ticks aren't quite the same time because one of them joined a little faster. And latency. All right, they both stopped at 40. Sweet. Well, I'm thrilled about this. I'm a little confused why this has a 0.0. That kind of implies this got turned into a floating point number. That being said, that doesn't actually matter, I believe, because Lua uses double precision floats. Double precision float, which, if you go to Wikipedia, it tells you that it has 52 bits of precision, which is so many bits. And noteworthy, 52 bits is enough bits to represent a 32-bit number perfectly. In fact, it's enough to represent a 52-bit number perfectly. So, okay. See, okay. What next? We have to do any testing at all. We'd find an effect. We tested it. We haven't defined any other effects. We're testing them more. I guess I just said I was going to do that. I'm not. I'm going to do that when I actually bring it into the game so that it fits into the piece. You know, when I actually make a bunch of example abilities, we'll see how the pieces fit and find bugs with that at the same time. This seems to work somewhat. Let's work on the. Let's knock this status effect. Let's worry about that. Let's do the client stuff. So we need the status effect effects, the visuals and audio, and we need UI. Just to say we need to build a UI element that shows you the status effects on you, and then we're going to go, when we bring it into the game, we'll put on a nameplate to do. Nameplate status effects. Okay, we are getting there. Let us worry about this one. So this controller has a client script. It's very simple. It can be more complicated. We are going to write a tick function. I believe tick is how we want to do this. We want to check everyone's debuffs every frame, see what changed. Maybe. I can do this one better. Okay, so the visual effects. Let me step back for a second here. One of the limitations of using custom properties over events is that you can't be sure that the custom properties will be replicated at the same time. A client script, when I go in the server and say, okay, I apply this into the player and it sets the ID and the start time, the client script might get them at different times. It might get there might be a frame where you read it, or even multiple frames, and the ID is valid, but the start time's not, or vice versa. For some things, that is like an unacceptable state, and you really need multiple pieces of data together, and you might not even, with some systems, know when they're all done. You can't just like read and wait for every value to change, because maybe, maybe the same dot's applied twice. Maybe there's a lot of ways this could happen. That just maybe one of the points of data is like how much damage and how much player dealt it. There's lots of cases where there's no way to know when all the things replicated. In this case, we don't care what the start time is for drawing effects. All we're going to do is watch the ID. If it goes to 0, we're going to destroy whatever we had. If it goes to something else, we're going to go look at that thing and spawn the effect on the player. Okay, simple as can be. Player in pairs, game players. I'll do this for every player, and we're going to have to store these effects on a table, which will be defined up here. Probably similarly to the thing I just did. All right, let's move you over there. All right, so the first thing we need is to call this function that tells us what's on a player. And see if this works on the clients. So there's a lot of the reason we did this sort of thing is that these functions should work on the client, same as they do in the server. We're reading custom properties, they're networked. Great. There will be one of these per player. Hopefully this is performant enough. Local effect. Where did I find this thing? I'm going to copy this guy over, even though it's not the same. It's the same structure. Effect objects. Player index int. Yep, okay. Well, now that I'm calling this function, I had the same problem I had before, which is that these are going to, the indices might change. Okay. I have a different solution to this problem. which might undermine the whole thing I did before, although it's not going to break it. It's just may not be necessary anymore. Instead of inserting this into this, let's see what this is called. Status effects. So we're just going pairs and ignoring the indices, so we don't actually care what the indices are at all here in this case. You see this? All right, and that's it. All right, great. So instead of doing this, we're going to use whatever indices they had. Result I equals data. All right. So this is 1, 2, 3, 4. If you have 1 and 3, it'll actually give you a table with only 1 and 3 in it. Returns name start time table may not have consecutive indices. So don't try to I-pairs it, don't try to pound operator it. You'll end up in bad space. Bad town, I don't know, it won't work. All right, so now we could have used this down here and used the old thing, but that works, so okay. So we got our effects, and for I data in pairs effects, do we actually need I in this case because we need to compare it to the custom properties, maybe? We need to store it into here. We're not. This already did the custom properties for us, but we need to know which one it was to keep track of it. I've got the itchy notice today. Okay. And we're also going to have to iterate through this to see if it has elements that are not here. And if they are, then we're going to destroy them. And we need the same thing we did in the API, where we add and remove tables from this effect objects. That. If player left, we should destroy story. That's important. If you leave, your effects that are on you should go away, not be floating in space forever. Yeah. The other scripts will handle those pieces for us, but this one we're taking care of, we're owning. Game player joined. Game player left. Okay. If not, objects player I then. All right, so this is the case, something new showed up. So this get status effects on player only gives us entries that are actual things. If it's, if the ID was 0, we didn't get an entry here at all. And now we've got one that wasn't in our table. Great. Okay, perfect. So this data has a name and a start time. Okay, we need that name. So we can access this guy and get the data and figure out what we need to spawn. Wrong script. Equal status effect data is data.name, and that is here, right? Equal effect objects player I equals world dot spawn asset. Status effect data dot, what did I call that? Effect template. Player. I should double check that that's how I should capitalize that. Socket names. Root. Perfect. All right, so hopefully that spawns the thing, puts it in the table, and attaches it to the player correctly. If it's set up correctly, it should start playing sounds. And then how do we go the other way with this? You know what I want to do? Where is that constant define? This guy right here. I'll put this in the API namespace. Move it down a little bit to talk about my previous organization, so I can access it here. Because I want to do both things, right? So instead of this, for I equals 1, do, and then if effects I or local, yeah, if effects I, then so basically what we're doing is data's not going to be defined, so we need to do that. Okay. So I'm going through all the slots and saying, okay, does this player have one and we don't know about it? That's one state. So, okay, let's find the name of it. Let's get the data, spawn the thing, attach them. And then, else if the opposite state, the contrapositive, that's probably not a contrapositive. If there isn't one, but we do have an effect, then we destroy it. All right, one more. All right, so we need to handle two things here. I mentioned up here, comment, we need to destroy these things when the player leaves. Second is, it is entirely conceivable that somebody else destroyed this template. That's not even that rare case. It's not like, oh, this person messed up as a creator. Like, yeah, okay, I would prefer they didn't do it this way, but someone may just, like, most effect templates that are used in other things have duration stuck on them, or you know, a sound effect or VFX that has an expire thing on it, because that's a common pattern. And I'm not going to make it so it breaks every time you drag one of those over and try to use it. It'll break a little bit, and then it might expire before your dot expires, or whatever. But I'd rather not have it script error and stop working entirely. So we're going to check if it's there. If it actually is a thing, then we destroy it. If it's, oh, you know, I need to set it to nil either way. Otherwise, this is not going to work. Yep. Okay, so let's move that up there, and okay. So if it's actually valid, we destroy it. Either way, we set it to nil. Simple enough. Then, if player left for blank object in pairs, effect objects player do. I probably could have saved this to a variable somewhere here. I'm just in the same table 3 times in a row. A lot of times in a row. Let's do that. Local object. Really? You're not gonna? Oh, it's there we go. That's all the places I'm using it. Bam, bam, bam. Yeah, I could have searched and replaced. Maybe I should call that something a little better. Effect object. Because object, as you see, is an actual type name here. It's not quite spelled the same, but okay. So we look at all the effect objects, and then we do this. We don't need to set them to nil because we're about to set the entire table to nil. If the thing is valid, we destroy it. Bam. Okay. That should be everything we need for spawning and destroying effects. Not so bad. Let's find it fail miserably. Bam. 31 in my client script. Grumble, grumble. I fixed that. 31. Effects I. If not, blank and. Why is there an and there? And effect objects. I lost one. Attempt to index nil field question mark. Ooh, that's new. All right, I'm gonna go fix this again. For what it's worth, this is totally fixed in the future. I swear. 168. Grumble. Okay, 201 in the API. What is that? And why is it not now? Oh, indexing by ID again. Okay, status effects on player. So I passed in the player here. This is on the client, presumably. Yes. Tick function stopped running because it didn't error. So we just tried to get the things on the player, and it came in here and said, there's your tracker. Ah, the tracker's not there yet. So this gave us nil. No, that would have errored here. Probably. So it actually got the property, got an ID. It wasn't 0, but then when it indexed the status effect ID table, it didn't find it. Is this not set on the client? No, that's in define status effect, which is called on, this is a stat context, it's definitely called on both. I don't need you. Did the IDs not match? That would be interesting. We're still printing the ID when we hit define it? Because that's only getting printed once. We are. Okay, why are we only printing it once? I'm wondering if this pattern doesn't work in single player preview. That would be a bummer. No error, but no burning. It should be really obvious that I was burning. It should be making sound and fire. Okay. All right, so I haven't thought about how this works in single player preview. I'm gonna have to talk to a coworker and see if I've made a thing that is hard to test. Not that I need single player preview for it to function, but man, is that really inconvenient when it doesn't work. But. All right, let's go agent ransack. This tool is very useful. This is how I find my log files, because see, this is where core save stuff. Logs. There's all my logs. Search by modified. This is the most recent one. All right, we're gonna drag that file into Sublime so I don't open Notepad. All right, so what I'm looking for is, did that print exactly this number? Control F, there it is. Error running load task. Hey. All right, the client script errored. Satisfy controller client 24 API. Yep, sure did. Okay, let's see what single preview does. Still errors. I still only print once. That's a bummer. That's what the ID table. So if it only has one instance of this, if it only calls this, if stat context only calls it once, does it still try to keep track of server and client separately? I don't know. let us actually just stick a breakpoint in there and see what it's telling me. 201. Actually, you know what I can do? I don't even need a breakpoint. It's hitting an error. So the default behavior of the script debugger, if you just do this, is that it will stop when you hit an error. Probably. Apparently not. Is that the next button over? That's the next button over. Bam! Hit it. Okay. So it just hit 201 in here, presumably. There it is. All right. Status effect ID table has nothing in it. Completely empty. API's got a bunch of stuff in it. Result, we haven't put anything in. Data, we haven't put anything in. This table is completely empty. Why? There is a possibility that we're just calling it too fast. Let's get Slime again. This is in a tick function. We don't initialize till here, but the way this generally works is this whole script, like, scripts don't do the same thing that, for people who have done multi-threaded programming in real programming, which is, you have to worry about the operating system just changing from one thread to another at any time. It can be in the middle of a line, and it's like, oh, time to go to something else. Scripts don't work that way. They're all run, I mean, the computer still works that way, but they're all run in the same thread. And it will run until it yields, or, you know, it's not going to run any of the scripts. So when it defines a tick function, the tick function is not going to get called until it's also done all this, which initializes this. That being said, the tick function might get called before it defines the other, before it actually runs the other script. That is possible. And our example, our test, well, the test was able to apply it. Maybe this is an ugly case with single player preview. Let's put a test.wait1 in here. And if that doesn't work, I'm going to split the static context and see if that fixes it. Oops, let's get over here. For loop must be a number. Status effect controller client 24. Client 24. Doesn't know what that is. Oh, why is that local? $274. Aha. This is interesting. I'm learning things about programming. Putting it in the API table didn't actually break this when it was local. Or maybe I'm getting further. 196 and 214. That's here too. Put a space before this to see if it there were any other places. Got them all. Okay. Still attempting index number, it can't. All right, let us, so I'm gonna take this out of the static context, duplicate it, and put it one inside the client context. This isn't the pattern I want, but we'll see what it does. All right, that is a bummer. The static context doesn't work in single player preview. I will see what we can do about that. It only runs once, but yet the scripts still have a pretty clear separation of client and server, like there's two different script runtimes and that sort of thing. So it makes it hard to test. We could probably change how that works. This is not a pattern that's been done very much. And even uglier, like if you're using a static context to spawn a procedurally generated world, you don't want it to run twice in single player preview. You don't want to spawn two copies of the world. So I don't know. That sounded like it spawned a bajillion copies, by the way. Also, my effect template has an offset in it, but we will helper, not that one. Template helper example.effects. Yeah, look at that. There's an offset. Let's fix that. Okay, I'll reset that. We're actually going to move this up a little bit. We're going to make it 100. And update that template so it's kind of near the middle of you. I'm on all the fire. All right, why is it spawning so many copies? Help, help, help. Oh, because I didn't put it in the table anymore. Ha, yeah, I got it. Got it. I made a variable and replaced every instance of it here. And then didn't actually put the thing in the thing. So in this case, this is nil. This and nil is not an object that they're referencing the same thing. So it comes in here. And I'm just reusing a variable, I guess. I could do that. I'm on fire. I should totally put this a little higher so it's in my head. Boom. Done. Sweet. I wonder if you want, that was a very abrupt ending. I wonder if I want to give it a, like, do we want to like try to fade out all the pieces? Try to do something smart. That was actually pretty jarring to me. Let's look at the API overview. How many things have fade out functions? Audio does. Smart audio does. Audio does. VFX do not. VFX, you could like set their properties and make them smaller, so maybe you'd have to be really smart about that. Humph. Especially since I'm destroying them, right? Like, I guess I don't have to destroy them. I could, if they're still there, I could do something other than destroy them and then set this to nil, and then I'm not worrying about them anymore. I could set their lifespan property and tell them to fade out if they have audio objects in them. Yeah, I like that. This is an interesting interaction. Something to do in the last 10 minutes here. See if there's anything else I wanted to. Status effect system UI. That's not going to take 10 minutes. That'll take half an hour. All right, local effect fade out time. We're going to try 1 second. All right, then we're going to define function fade out effect object. All right, so both places we're doing this. Destroying it. Instead, we're going to pass it to fade out effect. And if we just destroy, then hopefully this should work the same. I'm actually going to take this and make its duration 4 seconds, so this is easier to test. Okay. All right. So instead of doing that, effect object lifespan equals effect fade out time plus 0.1. I'm gonna give it a tiny bit of buffer. We'll see how that feels to make sure that the audio actually does it. Well, maybe not. Okay, it's fine. Let me make sure that lifespan, that's not how you got the spell span, is actually the property I want. Lifespan. Yep. Read write dynamic. Great. Just to say, I can write it, and dynamic means you have to own this object. It's a networked object or it's a client-only object. You own it. And then function I'm basically need a recursive function to find all of the Maybe there's a function already in here that can save me. Descendants. Find descendants by name, find descendants by type. Yeah! Great. This saves me from having to write a recursive function. For object in fact oops. There's fact object, that's by type. Fact, oh, that's already there. Audio. There are two types of audio. There's audio and smart audio. So we're going to do this twice. And for good reason. Audio objects are pretty simple and have predefined rules. Smart audio can do lots of fancy things and do lots of really cool things. Object fade out. What did that? Time. Great. That's all it takes. And since we set the lifespan, we don't need to destroy it. Lifespan will automatically destroy it itself. And the other one is smart audio. Okay. Three, 2, 3, 4. Hello? Why am I still on fire? What happened to the lifespan? Well, that's a bummer. I bet lifespan is defined in a bad way. Okay. I bet, well, bad is relative. Like, if I set the lifespan to 1 second, but the thing's already been alive for 4 seconds, it's not going to say go die in 1 second, or it might not. It might say, has it been 1 second? It's been a lot more than 1 second. I'm surprised that the sound didn't stay stopped. We could, print S. I want to see that we're not spawning multiple more objects here. So there's one. Just to, yep, still the same object, okay. So instead of doing that, we're going to do just a wait in here. And if we do a wait, then we have to be careful that the object still exists. If object dot is valid, fact object, destroy it. It's not valid, then it was already destroyed. Yep, sure forgot by then. Let me do that one more time, see how, did that feel like it was way too long? We could do, I have an even better idea for this. One more. What is the VFX type? Literally just VFX. Object scale 2. We want something that all VFX can do that will make them be less intimidating. That is at scale 2, 3, and number. World space or local space, that doesn't matter because I'm setting it to 0 and 0 is the same in either. Time, okay. Oops. Okay. Three, 4. I like it. I think I want it a little bit shorter. This feels a lot better. I'm on fire. Yes, excellent. Okay, that's really cool. All right, so up next, we're going to finish this off. We're going to make the UI element for it, and then we're going to bring it into the game, make the nameplate UI as well, and then we will, we might make the knockback multiplier. We'll probably just make a bunch more example abilities, testing both the ability system and the effect system. And then the damage API is the next big system. That shouldn't be that hard either. That might even be 1 day worth of stuff. It's pretty simple. Might even be part of a day. And the way I see this going is once I have these pieces, I don't see any of the large pieces I'm missing. There's a lot of cool stuff I could write, but I want this game to be playable and fun. So I'm going to work with my friend, try to figure out exactly the trees we want and the abilities we want, and just start building abilities until we've got, you know, if we had 20 talents in 8 different trees, like that's a lot of things, but a lot of them will be similar. And I think that would be a really cool pattern and a lot of fun. So we're going to do that. And then we'll play it. Thank you everyone for watching. I appreciate you coming along. We will get back to this on Monday. Thank you again.